How's everybody doing? I know you started pretty early, and hopefully you are fully awake by now. My name is Bikash Koley. I'm the CTO of Juniper. This is my coming up on my 6th month here. Spent about 10 years in Google before that. So my team used to design, build, architect, operate Google's production network. Have run, build, designed very large software-defined infrastructure for a large chunk of my career. And one of the things that I actually wanted to share today morning are lessons learned when you run an infrastructure where your data center has 10,000 switches, moving to 100,000 switches, and a network has tens of thousands of routers, and the principles that you learn in both designing and building an infrastructure at that scale, and how do you apply that as a generic principle to other networks that may or may not be of that scale, that may or may not be solving same set of problems, but are there principles that are actually applicable to those, right? And one of the things that I actually learned in many ways, in hard way, is that when you actually have a large infrastructure, you cannot treat your networking elements as pets. You have to treat them as cattle. You cannot go and tend to individual elements as if they were the most precious thing in your fleet. You basically got to treat them as a fleet and find out the characteristics that the fleets have, and then apply those characteristics. Why is this important? It's important actually for a couple of reasons. When you run a really large infrastructure, there are a few things that you sort of start learning, and those are that ultimately the beauty of an infrastructure is when it's invisible. And it may not be invisible to you as an operator, but you absolutely want it to be invisible to your customers. And the customers could be applications, customers could be users, customers could be others who run services on the infrastructure. And there are some fundamental properties of an invisible infrastructure. The interesting part is that if you look around and think of the infrastructure that you use every single day, electricity, water, internet to some extent, they actually have some common principles. It starts with fungibility. You basically have an infrastructure that allows you to use exactly as much you want, no more and no less, and you effectively pay for that amount of infrastructure. So in the case of network, again, it's not the number of switches and routers that you have, but it could very well be, I have this bandwidth with this service level assurance that is available for this much time, right? So it must be fungible. Reliable. Reliable is something that is often very hard to achieve because it starts with how do you define reliability? Is it packet drop on a switch? Is it completion of an RPC? Is it uptime of my fabric? What is the definition of reliability, right? But end of the day, people are looking at an infrastructure where the services that run on top of that, it expects that you're going to get the service level assurance that your services have, right? So it has to be reliable. Secure. It's especially true with today's ways of building infrastructure, where the old definitions of segmentations and perimeter and having boundaries between privately owned infrastructure and publicly owned infrastructure are basically disappearing, right? It is true for users. If you are a large enterprise, your users are working from Starbucks on an open Wi-Fi, or if you're an application owner, where your applications might be written on an on-premise data center, and you want to move that to AWS or Azure or GCP based on economics, based on ease of migration, and many other things, economics, right? And finally, ubiquity. You want your infrastructure to be available everywhere. And that is, in some ways, this has always been the promise of cloud. The promise of cloud has been, I write it once, and I have it available from wherever I am. And I have it available from whatever endpoint that I'm accessing my infrastructure from, be it storage, be it compute, be it application, right? Interestingly, you can apply all of these things to running water. It's fungible. You pay for as much as you use. It's reliable. You can have your tap, and you expect water of certain quality. It's secure, and it's ubiquitous, right? Great infrastructure always follows these 4 principles. And the promise of cloud is effectively to be that infrastructure, right? And the interesting part is that if you sort of break cloud down into what ultimately is cloud, it's compute, storage, and network, and then the application on top. And for this promise to work, all this fundamental part of cloud, compute, storage, and network, they have to follow the same principles. So it's critically important that the network that is being built underneath ultimately follows the principle of fungibility, reliability, security, and ubiquity, right? And where I'll actually spend my time on today is, and I'll not spend a whole lot of time here, maybe just flash this for a second. This is actually showing an example of an enterprise, but you actually can take the same picture and you can turn that into that of a telco or a cable provider or even a hyperscaler. Conceptually, they're about the same. You actually have a mix of infrastructure where you started out with a lot of things being on-premise. You possibly have a set of colocation facilities where you either keep your, if you're a telco, those are your edge POPs. If you're an enterprise, those are often places where you apply security and things like that. And you want connectivity to public cloud. And of course, the reality is that most of the infrastructure today are a subset of this. Not everybody has all pieces, but it's a pretty generic picture that sort of that shows how any of the modern infrastructure looks like, right? Now, if you try to apply the principles that I talked about before just on network, forget about storage, compute, and applications that run on top. If you want to apply the principle that I described before just on network, there are a couple of things that you need. One, you want to treat this infrastructure as a cattle, not as a pet. What I mean by that is if I have a data center that is on-prem, and if I'm extending that to, let's say, Azure VPC or AWS VPC, where I have a virtual data center, effectively, because I run a bunch of VMs on a bunch of networking nodes that forwards packets and applies policy, there is no reason they should look different. Because ultimately, to you, what you're trying to do is you take a bunch of applications or users that sometimes run on-prem, dynamically move off-prem to public cloud, and ideally moves over public internet where it extends all of its security postures and policy as you do it, right? So our goal, in my opinion, is to build a network infrastructure where you don't have to worry about the boundaries between public and private, and the boundaries between physical and virtual, the boundaries between, is it a router or is it a virtual switch that runs on a server? Because end of the day, your applications don't care. Your applications don't care whether an HTTP session led to a TCP session led to a packet that was traversing a silicon on a Juniper router, or it was getting routed by an x86 somewhere. For the applications, it's exactly the same thing, right? So the vision that we're actually pushing very hard towards at Juniper, and I'm going to share some of the technical details of how we're thinking about this, is how do we build a network infrastructure where you don't have to predetermine what is physical or what is virtual, what is managed on-prem or what is managed off-prem. You can dynamically move resources on-prem and off-prem without having to rethink of what network you have or what policy you have or what security you have. That's in many ways, the nirvana of fungible, reliable, ubiquitous, and always available, right? Network. So how do we get there? We get there by effectively applying the same principles that many of the hyperscalers have applied for a long period of time in building very large scale infrastructure. So let's start with sort of the fundamentals, right? What does network do? It connects. It sends packet in short distance. It sends packet in long distance. It switches packets, and it blocks based on policy if it's necessary, right? The main thing that has happened over the last 10 years, in my opinion, is that people have figured out different economics of how to forward this packet. There are a lot of discussions on SDN and white box and NFVs and et cetera, right? If you ultimately peel it all down, and if you look at the principles, what you're really after is what's the best economics for me to forward packet or switch packet. It just comes down to economics. It's not philosophy, it's not religion, it's not principles. Even though a lot of people make it religion, if you actually ask anyone who has worked on really large SDN projects, I was part of the team that built Jupyter at Google and B4 at Google and Espresso at Google. It is never about religion. It's almost always about economics. What's the cheapest possible way for me to forward packets? And if you look at it, it ultimately comes down to what applications are driving those packets. So there are applications that require very high rate of lookup along with speed and feed. And what you find is that if you try to do that on an x86 processor, of course you can do it. It's going to be very expensive for you. The equivalence of that is, can a CPU render your latest and greatest video game on a 4K screen? You can, if you have lots of CPUs, you have lots of bandwidth connecting the CPUs together, and effectively if you're willing to spend a lot of money. Instead, you build GPUs because they are optimized in hardware to render a screen at a very high rate at the lowest possible cost. The separation between CPU and GPU are, again, it's not religion, it's economics. It's the exact same thing for network. But then there are applications where you might need massive amount of programmability in terms of how you look up packet, how you apply policy. You want to make the policy very rich because your policy might be, I have this application tier, let's call it web tier for a second. For these applications, for this user group, I don't want to allow these applications to talk to the storage tier of this user group that happens to be on public cloud. That's my security policy. I'm making this up, right? A policy this complex is often hard to encode in a pre-done ASIC because you may not have enough table size or enough abstractions to do it, right? Well, x86 or ARM processors work great for doing that. So those are the scenarios where you say, I need a table size which is dynamic. The table lookup changes based on the applications that I do. And whether I look at merchant silicon or the greatest NPU that Juniper does, I still have a fixed table size. It might be a couple of million in something. It might be a couple of 100,000 in something else. Not enough because I'm actually building richer and richer policy. So L3 cache on x86 is your friend. Or RAM on an x86 server is your friend because you have gigabytes of table size, right? That's when you use virtual, right? The thing that we want to completely remove from this, and this is sort of mission of this company, has been much before I joined. Absolutely, I feel very passionate about that. Is doesn't matter how your packet gets forwarded underneath, your application should see the same thing on top, which basically means that you want the same abstraction for your forwarding plane. You want the same abstraction for your control plane. You want the same processes to run. You want the same abstraction for your management plane. And this is the goal of Junos. What we're doing with Junos is how do we take, irrespective of the way that you forward packet, we expose the forwarding plane with a common abstraction, which we started out with something called AFI, and we're basically adopting P4 across our fleet. P4 is our mechanism to expose the abstraction that you need for the underneath switching. And by switching, I don't mean silicon. I mean abstraction to forward packets or switch packets. Could be silicon, could be x86, could be something else, right? We're doing the same thing with control plane. You may have seen an announcement from Facebook where Juniper is supporting their OpenR agent on our control plane. Using our standard API called Jet API. And again, the idea being that the control plane state is mutated by Juniper applications like Juniper's BGP or Juniper's RSVPT the exact same way as your own applications that you might be writing on box or off box. We'll give you the exact same API to go and mutate the state that you have on the box. And the third is management plane. You might have an application where it's not worth your time to write control plane protocol. I mean, BGP works great, or EVP and VXLAN works great for your use case, but you want to manage this infrastructure that you have underneath as cattle, not as pet. You want to have this ability where I started out with, let's use another example. I started out with doing EVP and VXLAN on physical hardware on my data center. And I had all these policies that I wrote, which allows me to do segmentation of my applications. Maybe I did microsegmentation by throwing a set of firewalls, physical firewalls. And I see the economics of public cloud now. I want to move this infrastructure to public cloud without affecting how my applications are written. The way we offer a solution to that is Contrail gives you EVP and VXLAN overlay that runs on x86, gives you the same microsegmentation policies that used to be on possibly SRX, but you also have the ability to take SRX with you on a public cloud and run it as vSRX, and you have the exact same replica of the infrastructure that you had in your private data center. Same operation, same policy, same ways of managing it. You have magically taken your infrastructure that is on-prem, moved it off-prem. It all starts with building the right abstractions and the right operating system on top. And it starts with, as I mentioned, Junos, that gives you the abstraction for control, forwarding control and management plane. And it finishes off with Contrail having the common orchestration capability, irrespective of whether you're orchestrating a physical or a virtual network. This, by the way, is a significant enhancement to what Contrail originally did when we built Contrail. It still happens to be the #1 SDN for OpenStack. It is the most deployed production-grade SDN, which runs. AT&T has announced this in public domain, so I can mention, AT&T's NFV infrastructure runs on Contrail, one of the most demanding environment where people have done really demanding applications, right? Has been used and proven as an orchestration system that does scale-out management and orchestration and provisioning and policy enforcement for large infrastructure. We're taking the exact same concept, and we're extending that to physical layer. So now you have the ability to use Contrail to not only manage your overlay, but manage your underlay. And to be very clear, frankly, I actually don't care whether it's called underlay or overlay. It doesn't really matter. It's whether you route packet on silicon or you route packet on x86. It's the same thing. And we want to make it the same thing, where people don't have to think about whether it's overlay or underlay. People don't have to make the choice of, I'm doing SDN versus I'm doing physical network. It's the same. It doesn't matter. I have the same ability to go and orchestrate and manage and apply policy and do security, right? So connect, we're giving the ability to connect endpoints in an infrastructure in a way that it spans the physical and the virtual boundary. Pretty much every product that you have in a product line actually has a virtual counterpart. MX has VMX. It actually runs about the same, with almost the same performance as a physical MX, modulo the limitations of the ports that you have in a server. Same thing is true with SRX. It has about the same performance as it runs on a virtual version. Again, modulo the limitations of ports that you have on a server, right? We're creating a CPE device where, again, the goal is you can do service chaining and you can bring up and down VNFs where you have the same capabilities that the VNFs do, right? So connect, orchestrate. Contrail is our mechanism for doing this orchestration. I'm going to go down into a little bit more details as to how this orchestration platform works, but I'm sort of setting this up as to what we're solving. And once you have done that, the next bit is C. I'll not spend much time there because you heard a lot about what F4mix is doing this morning. With C, again, our goal is the same philosophy as before. When you have an infrastructure and you want to get visibility in the infrastructure, you shouldn't have to separate between whether it's physical or virtual, whether it's in public cloud or my private cloud or even bare metal. You should get the same pane of glass visibility for compute, storage, and networking, irrespective of physical and virtual. And you should get the capabilities to not only just see, but do other things with it. And the important part, operational analytics, state-driven orchestration. If my infrastructure is going sideways, I have the ability to fix it because I have smarts in my visibility system, which are the machine learning examples that you actually heard before, and do state-driven orchestration. Role-based monitoring and alarms. I may want to know when things are going bad based on some thresholds that I put in. And capacity planning, critically important. The last bit is often overlooked. Like, let me give you a concrete example of this. I am a service provider, and my business is selling VPN at the edge. And I have this edge router that I bought, and I actually have no abilities to run. And by the way, this is all control plane heavy application. This is not necessarily data plane heavy application. I actually don't know how many sessions I can support because I have no mechanism to actually know how my routers behave as I keep on adding sessions to it, right? Our goal here is, again, to give you a common mechanism to collect data, process data, and store data in a way that the data store itself is not different for for actions that are taken in seconds, state-driven orchestration, or actions that are taken over weeks or months, planning. You don't have to go and look after and go and find two different data sets and apply two different mechanisms to do planning. It's the same common data store and same behavior.
Can I just read back my understanding of what you're talking about here? Because I think there's a few things going on. There's a whole bunch of gears spinning. So down at what you're saying is that, I think what you're saying is that Juniper's moving to embrace physical and virtual devices, that the control plane for those will be driven by a P4 abstraction over time, so that you use P4 as a language to define packet forwarding, and to some extent the application rules. And then you're talking obviously about the SD-WAN type of environment where it's applications at the edge and then packets in the core. True?
Approximately true. So what we're saying is we are giving you the capabilities to control Juniper infrastructure at any layer that makes sense for you.
Right.
So if for you it makes sense to control the forwarding plane, you can with P4.
Yep.
For many, that will not make sense. For many, you want to control it at the control plane. So
yes.
for that, you have
in which
Jet.
case, and so then to read further up the stack, then
that's right.
Then it becomes Contrail.
That's right.
To do the configuration and
that's
deployment capabilities.
That's correct.
And then on top of that, in the last slide, you talked about AppFormix becoming then a combination of analytics engine, giving you data about the combined state of the devices, the configured state of the operational network platform. But you're also saying that this becomes an automation platform then for DevOps operations.
Yes.
So again, this is getting away from a network as a devices to the network as a platform, so that you can pull a lever and the gears all clunk down and then it all trickles down. So that becomes, in very loose parlance of the current state of word, intent/policy/ application-centric, depending on which flavor of buzz you wish to apply on top of your thing. You know, this, I want to make my network go faster here, click faster here, please.
Yes.
And then the engine can then divide. AppFormix will say, yes, there's a performance problem here. I can measure this. Then I will send some configuration commands to Contrail. Contrail will work out how to add bandwidth at this point in the system. And then it would then go make the appropriate changes and so on and so forth. And that's sort of the vision that you're laying. Or
I couldn't have done the summary any better. Yes.
Okay.
And what I was actually going to do is I'm going to skip this slide. Let me go into the details of how we're doing it.
Okay, sorry. I just wanted to read it back because I was.
Yes, exactly. You actually described it perfectly.
Right.
So the vision is exactly that. The interesting thing that I actually wanted to share with you is that it's not a vision. It's actually very close to reality. And the reason being that we started out with a large number of these building blocks that are already there. So Juno's always had these capabilities of programming at every layer. We added P4, so there was AFI, we added P4. So it's not really new, it was there. Contrail always had the ability, so Contrail had a very strong intent and policy language from the beginning. And it always had the ability to go and orchestrate thousands of endpoints. It just happened to be virtual when it started out. AppFormix started out its life, again, as managing applications and can do hundreds of thousands of endpoints and collect telemetry and make sense of that, and you saw some of the demo, right? We're really putting these functions together. And the real change, I don't call it change, evolution is a better word. The real evolution that is happening is what we're really building is a common platform as a service. So its internal name, it has an internal name. You will see externally it's referred to as really the applications that run on top. And we have been calling them bots. So you might have heard named peering bots or test bot or health bot. The basic idea is we're building this as a real platform as a service where you have clearly defined northbound APIs, and these are REST. So there'll be either Juniper applications that will drive them, or somebody else can write applications because they're clearly defined APIs. They have clearly defined data models. So intent, intent is used loosely in various different ways, right? But ultimately, it comes down to, is there a clearly defined data model that allows me to talk to the network, not to the switches or routers, right?
Yeah, intent's a very complicated issue.
Yes.
I think ultimately intent is, I don't want to know how it's done, I basically want it done.
Yes, and manage the cattle and not the pets.
Yeah, or even manage the pets, but only tell me when it's broken.
Yeah, sure.
Right, we're seeing some intent-based systems say, in the data center say, these cables are wrong. Right. Well, my intent is actually to have a working network.
Yes.
If the cables are wrong,
Yes.
then I can say from the policy that you should go and fix those cables.
Absolutely.
Right.
Absolutely.
At its most simplest
Absolutely.
reduction
Yes.
of the logic. Whereas more complicated is, I've got an MPLS backbone with 4 carriers in the back of it, and I've got my analytics visibility platform. In the case of Juniper, it's Appformix, telling me that there's some sort of brownout.
Yes.
Of bandwidth brownout. I'm not getting enough.
Sure.
So I either have to go and kick the telcos to provide a decent level of service, or just go and buy more bandwidth.
Or reroute.
Sorry?
Or reroute around that path, that LSP.
That's right. Yeah, I'll just focus on the networking
Sure.
and not talk about. You're also able to. The demo from Appformix was also talking about scaling up the capacity in the cloud. So
Exactly.
if I have a service brownout and it's actually due to a lack of web servers in my
Yeah,
and then I can start to send commands into whatever the backend system is and say scale up the number of instances.
yes, and you can extend that to SD-WAN, from Juniper's perspective, SD-WAN is a feature, it's not a product. It's a feature where it's another way of connecting from A to Z, and so it's the same intent that then say, I was using this VPLS network from somebody, and I see a brownout there, right? Do something, and the do something might be using internet or moving to public cloud, or it's not just the network moving the workload to public cloud.
No.
Right. So yes, your description is exactly right, and the approach that we're taking is exactly how hyperscalers have built this infrastructure. So if you actually look at this picture, you'll find lots of similarities with Kubernetes. This is built using almost the same principle that Kubernetes uses for orchestrating services. This is for network.
So you're alluding to a microservices model?
So it is absolutely microservices.
Right.
It uses the exact same principle, as in, just as Kubernetes has a manifest, this has an intent, and it pushed down over a clearly defined REST API.
Right.
By the way, this part of the picture is completely leveraging Contrail with evolution. This part of the picture is completely leveraging Appformix with its evolution. And what it's going towards is you have a clearly defined state database for the network. We call it IntentDB and ConfigDB. It has 2 levels of abstractions that are captured. Similarly, on the Appformix side, there is a telemetry DB that keeps the telemetry for the whole infrastructure. At the bottom of this, you have plugins.
Yes.
So the plugins are both Juniper specific as well as non-Juniper.
Yep.
And these plugins are what do the translation. Loosely template, but this is not really template. These are actual plugins, software plugins, right?
So you'd have plugins for each model.
Exactly.
Of the physical virtual infrastructure
Exactly.
that underlies it, and that would be customer led.
That's correct.
Yeah.
And for Juniper, all these plugins already exist. We use them. Contrail always had these plugins.
Yeah, they exist for all of the Juniper stuff, and you'll extend.
And you'll extend that for.
If you're going to build a platform that's viable, then.
So long as the underlying platforms allow real configuration push, we'll not do CLI hacking. I mean, somebody can write a plugin that does CLI hacking. They're welcome to do it. We'll not do it. But as long as somebody support modern ways of pushing configuration, if you have RESTconf and Yang or gRPC and OpenConfig, we're good.
Yep.
We'll support that, right? Same thing with telemetry. So there are plugins where we already have plugins for Sumit. Please keep me honest. Of course, all the cloud stuff that happens for storage and applications, but SNMP, SFlow, NetFlow, UDP streaming, gRPC streaming, right? Standard stuff that comes in. And there are a bunch of service primitives that we're writing. Again, this is very similar to if you look at Kubernetes, there are some applications that are embedded. kubeproxy is an application that are embedded. So we actually have a bunch of applications that are embedded in the system that are commonly used for almost any application. Inventory database, for example, right? And then we give the ability to write application on top, which these are the things that are called bots. And we're already releasing a set of Juniper bots, but ultimately this is going to be a large chunk of this, not all of it, a large chunk of this remains in Contrail and therefore will remain open source. So all these APIs are going to be published openly, and this is usable for others to go and build an ecosystem. So the thing that I want you to leave today with is that the abilities to manage a physical and a virtual network as a system with clear definitions of APIs and data model, it's not a dream.
No.
It's actually very real.
If you don't look at this and go, the CLI's just not a part of the long-term future,
Yes.
you've got something really wrong with your head.
Yes.
Because this is all software layered on top of something, right?
Yes.
And whether it's a Juniper MX80 or a white box or a, running a Junos on top of a white box switch, or it's a virtual server at the edge, or it's AWS or Google, there's no CLI in here. It's all, and it's all got this, I know I've been banging on about analytics and visibility for the better part of 18 months, but this is the integration of the analytics engine with the configuration engine. And that's that feedback loop closing up.
And then the applications close the feedback loop, right? And some of those applications would be ours, like HealthBot is a good example, or Formix has a set of applications that close the loop. You will be writing applications for sure, right? that people will write applications where they'll close the loop in the way that it makes sense for them.
The challenge here is security, because firewalls and IDSs and IPSs, and that's the gap that's missing, that's not being addressed here.
Actually, it is.
But you'll be evolving into that.
So it is being addressed. So let me talk about that. I know we're a little bit over time.
I'm sorry.
Spend 30 seconds, maybe.
Okay.
Talk about security. We're going after security in 3 different ways.
Yeah.
One is, as I said, our firewalls are virtualized. They're actually containerized now. So CSRX is a tiny, small footprint. It's 25 megabytes or something. It's a very small footprint. That can run, it already runs natively in AWS. It'll run on GCP and Azure. Actually, I think the Azure integration is done. So you can take what you have done with physical firewall and take that and plug that into their infrastructure. Contrail announced a thing called Contrail Security. What the idea is, Contrail vRouter already has a stateful L3, L4 firewall.
Yep.
With that, if you add a CSRX on the side, you actually have a L3, L4, L7 stateful firewall.
Yes.
And this is fully distributed. So it's actually not a perimeter security at all. So at that point, you can go and push security into, and by the way, this is one of the reasons that a lot of our enterprise customers use Contrail, because it gives them microsegmentation.
You're then starting to get into the sidecar proxy model.
Absolutely.
Where you're running a CSRX on the side
Yes.
of every container to give you
Yes.
visibility and control.
Yes.
Yeah.
Yes. And by the way, this infrastructure is being built absolutely to support that. So
Right.
the policies are not just network policies, the policies are security policies as well.
Okay.
So you go and you push the security policy based on whether it goes into physical firewall or virtual or...
We certainly have some security, because all of a sudden we've got visibility tooling.
Yep.
And we've got configuration
Yep.
tooling.
Yep.
But it's just those legacy appliances that
Yep.
have to go in the middle of those flows, because legacy is really important, apparently.
Absolutely.
Like stupidly important. But,
I mean, the reality is, I have never seen any of these changes work when you have assumed that legacy has disappeared, right? Because
Yes.
you have to assume the legacy is going to be around for a long time.
yeah, so your foot's still now.
And you have to take it with you, right? And again, that's the other approach that we're taking. So thank you very much. I know I've taken more time than I had, but I'll open it up for questions if you have some.
Just a quick one to the security. So you see, the end vision is you have the complete transport in one, let's say, pane of glass, and the security is just one
Part of that.
part of that, or an additional tag or
Yes.
feature that you can just add,
Yes.
and it is distributed, and you see that also in the whole package as just one feature.
Yeah, I mean, my view of security, actually, Juniper's view of security, you may have heard the term SDN, Software Defined Secure Network. What it really means is, just as here we're saying, you don't go and configure individual routers, right? You don't go and write security policies that says, block this in this firewall and block that on that vRouter. You say my policy is, in my application level, or in my user level, these are the things that I allow, right? Then the system goes and processes that and figures out, okay, I need to now follow this application because this application is moving into cloud. So I need to take the same microsegmentation possibly that I had on-prem, now it moves to cloud, right? And that is done by software. Like a human is not going and figuring out, now I need to go and plug a bunch of firewalls in AWS. So that's the vision. We're not there yet. We're getting pretty close to that because, again, CSRX and Contrail Security gets us really close to that vision. We'll be there by end of this year, I would say.
Okay.
That's where we are. Okay. Thank you very much for your time, and really appreciate you guys coming over. Thank you.
Yeah.